Okay, we have installed the software, and if there was no error message, you can go ahead with finding the software on your computer and starting it. And I find it via the search button here. I recently used the software, so it should pop up there. And if it doesn't, just enter QGIS in the search window. So we double click on the app to load it, and it might take a moment depending on how strong your computer is. That's where it is. And what you want to do is start a new empty project. So on all these things here that you see, you want to click here on project templates, new empty project. Double click on it and it should load. And what you want to do first is save that project. You click on project, save as, and you find a place to do. I have a folder here, the Africa Field Course folder, and I want to call it Lishiba Mapping. You can edit that, of course, if you wanted to do another version, but I keep that. I will override what I have, and then I save it. So that's now my project being set up. Now that software, QGIS, is used for display of spatial data. It doesn't actually change the spatial data unless you ask it to do so via some processing tools, and then it would create new outputs. So in a way, it's a really great tool to just play around and try things out. And if it fails, just shut it down and reload it, and then start again with the display. Now, what we want to do is explore the spatial data, the satellite data, as I previously said. And how we do that is we load them into the software for display. So you click on Layer, Add Layer, and Add Raster Layer. And then here, you can see this window, the raster function, and you want to go on these three dots here, click on them, to browse to where the data set. Now my data set in a folder on my computer, which is called In the Field. And then I have all these data sets here, and you should have the data on a memory stick perhaps. So it's a satellite data set in here, and I have two types of satellite data, the Landsat one and the Planet one. Let's start with the Landsat one. And what I want to perhaps load is a TIFF file, obviously, a GeoTIFF file. And we can start with the NDVI map, perhaps, which is just one raster file. So if we click on that and we open, we click on Add. Let's just close it for a moment. This is what we get. And it's quite a large area covered, and it's quite difficult to see for now unless you're used to the data where something is. We can, of course, change the display, and I will come back to that in a minute. But for now, it's just like, okay, so the task is, where are we? Where is Lishiba, right? Okay, so one way of doing that is to add another layer. And this is called a vector layer. Now we want to load some point data where we know we have been to the study area and have set up some camera traps, so that will be good for orientation. We have different kinds of shape files, so these kind of point data or lines or polygons which indicate an area. And what I will display is the location shapefile for 2024. This is basically points where we had previously set up camera traps and microclimate stations. We can see the whole file path. We want to load the SHP file type for that name. So locations 2024 shapefile.shp. We add that and then we close. And we can see, okay, this is where the camera traps are. So this should be in the Lishiba Game Park. Now there's two ways to get a closer look at those locations. We can use the zoom in function. So if you click on this plus up here, and when you draw by holding the mouse, the window around them, this is where you go. The alternative is to click on that location's shapefile in the layer panel, to right click on it and say zoom to layer. Now it's still not very informative because the NDVI map literally is a vegetation greenness map. You could display it, of course, in different colors, saying, okay, show me the dense green areas, forests perhaps in dark green, and the not so green areas in a different color. In order to do that, we double click on the layer. Did you see that? I can repeat that. Double click, go to single band pseudo color in the display here, choose a green color ramp perhaps. I like the green color ramp. I stay with that. And linear, I'm only interested in values from 0 minimum to 1. That's the maximum you can get for vegetation greenness. And then it will classify them here. You could add different colors. You can change the colors if you want, but I like this and apply and okay. So what do we see now? A little bit more. You can see the denser green areas here and the lighter green areas where the grassland is here. Still not very informative for orientation unless you know exactly where the camera traps were. So what we'll do is we load another raster layer. And this time we load the overview satellite image where all the information is still in them as if you would see it in Google Earth, perhaps, although it's slightly different resolution, spatial resolution. So you click on the Sheba 2024 and you add that, and then you close it, and it looks a bit more like that. It's not very pretty because you have to change the color combinations, so it makes more sense. Now in order to do so, you would double click again on that file name here, and then it brings up the symbology window. It automatically says there's many bands in there that you want to put together. So it's a render type multiband color. But what we want to do is change what kind of data are being loaded on the display. So what we will do is on the red band loading here, we will choose band 5. On green band, we will choose band 4. And on blue band, we will stay with band 3. We apply that, and then we look at how it looks like. And I find that quite informative. So what does it show? It will show you the dense vegetation areas, forests in dark red. Less dense vegetation is shown in lighter red or in greenish whitish. And then you can also see water in blue. I will zoom a bit out so you can get a feeling for the landscape, right? So what you can see here already is Louis Trichardt in the corner down there. Some agricultural fields down here. This is the big road that leads along the bottom of the mountain. Our plots are here, so obviously there must be a road that leads up in the mountain to the Sheba Game Park. We can zoom a little bit in to see a bit clearer what's going on. And I know that this point here is the point near the Wonderbush camp, is where that little water overflow is. So the bush camp is actually right here. The reception area is somewhere here. The river that leads through the valley is here, with some camera traps that we set along there. Then there is this ravine up here that leads to the other bush camp. And then the points at the lake with the tree and the spring, they are here. So we sort of can orientate now ourselves on where we are in the landscape. What else would we like to do? You can play around, right? You can just change the display maybe to something what you're more used to. You could change it to load the band 4 on the red band, the band 3 on the green band, and the band 2 on the blue band, and look at how that looks like. And what normally should happen is that vegetation is shown here in green. It's not looking great. It's not looking fantastic. So I don't quite like the display itself. It might be due to the mountains. You could try changing minimum maximum settings for the values. Maybe just do it to the extrapolation for the display is really just for the display, improve that, increase the contrast, but changing the calculations to current canvas, maybe makes the estimate of accuracy to change it to accuracy slower, and then apply that, and then let it do its thing, and then click OK, and let's see what that then happens. So for me, that doesn't work very well. So I prefer the red display, but yeah, I'll leave it to you to decide. And there's a couple of other things you can do, and you can play around with those points, clicking on them to see what they do. Yeah? Okay. What do we want to do next? We do have other satellite sensor data. These are stronger satellite sensor data, or stronger meaning higher spatial resolution, so you can actually see a lot more detail. And we could do that in the next video. Okay.